Okay, so as far as conventional timers are concerned, over here we have, this is our timing relay. Now, when we look at a timing relay, do we know how many contacts are on a standard relay, or is that something we can buy? That's something we can choose when we buy it. Yeah, we can choose them, right? And so there's two types of contacts on any particular timing relay. You have timed contacts, and these are the ones that change state depending on the timer, and then we have just standard contacts. Okay, so the standard contacts, when you buy a timing relay, they all usually come with a set or more, depending on what you specify, of standard contacts, and they act just like they do on a normal relay. Your timed contacts are based on your actual timer. So what we're going to do here is we're going to go through and we're going to talk about what happens in this hardwired diagram, and we're going to actually write some stuff in, and you guys should be able to follow along. So we're going to start by closing the stop, or the start button rather. So when we close the start button, what happens to the timer TR1? It energizes, right? Okay. So if we do that, we're going to start by looking at our standard contacts. We know that the coils de-energize. Is it fair to say that they are normally open and normally closed? So if you have normally closed contacts, they're still normally closed. We haven't done anything yet. But as soon as that timer is energized, what happens to normally open standard contacts? They close. So these become, I guess you wouldn't use the term normally closed because that's not normal, but they close. Okay, so perhaps close would be a better way of describing that here. So we are going to close these contacts and we are going to open these. So a good idea, or one of the things we can do, is you'll notice that these contacts right there are making reference to the timing relay. Now here's the question. That symbol there, is that showing us the timed contacts or the standard contacts for holding? Standard, good. Okay, what is this? I'm going to remind you guys of what a timed contact looks like. There's a couple ways of doing it. So timed contacts, if we look at a set of normally open contacts, could look like a normal set, but usually this will say time delay on energization or time delay on de-energization if we have an off timer. Hello. Thank you. Yeah, don't go to sleep. What the hell happened there? There we go. Okay. So the point being is that this is going to be, it'll say TDOE or TDOD. Now another way of showing these, and this is very important, is this. Like that. That is a symbol for a set of normally open timed contacts. How do we know that? What part of that symbol is telling us it's timed? Yeah, the little white bottom, the little arrow right here. That's telling us it's timed, right? Okay, now you guys, when you go through your lab pack, I think there's a lab you actually have to do. You don't actually even get me to sign it, but I will be looking to see if you did it, because that kind of doesn't get you extra marks, but it helps keep you at 100% of your lab mark if you actually do them all. So let's call it an elective lab. It's one you can do or not do, it's up to you. But the elective lab will actually take you through this, okay? And it'll show you that that's the symbol for timed contacts. So again, when we look at our holding pattern here, even though it's making reference to this timing relay, and by rights, it should say TR1, shouldn't it? I'm kind of missing the 1 there. So that just tells us that it's using the regular contacts in the timer. Now, again, we've closed the start button, so we automatically know those contacts are going to close and give us a holding pattern. That keeps the timer engaged. All right, so at this point, when we're talking about a time delay on energization, that is exactly when the timer starts. So the timer at this point will start, okay? Now, we know the timed contacts at rest, if they're normally open, are normally open, and normally closed, okay, before we energize the coil. When we energize the coil, do these contacts change state? No. So at this point, when we energize that coil, the time contacts are still open and closed, depending on the contacts we're using there. All right? Now, when the timer times out, now what happens to our contacts? They reverse, they close. So now, once we're timed out, these close and these open. All right? It's important you understand how the conventional timer works before you try and attempt to program the timers in your PLC. The reason being is they operate almost identical. Okay, they operate exactly the same way, but you need the foundation here before you get into that. Now, at any point during this process, let's say this is energized, and all of a sudden somebody comes and cuts your wire. What happens to the coil? De-energizes, right? So at that point, does my timer keep timing? No. Okay, so in other words, you're going to have this situation. It's going to just stay normally open, normally closed. Right? Make sense? So let's go to time delay on de-energization. Again, we're showing a hardwire program here and a couple symbols for it to make sure you understand what they look like. They would look something like this. So if we're going to show standard contacts, this would say TDOD. And again, another symbol for timed contacts would be, and again, I'm showing normally open here, right? So normally closed would be the same thing if we would show normally closed instead. So I'm going to show normally open, except this time, take a look at your arrow. All right, so the arrow is telling us that that is an off timer, which, by the way, you guys, that's another way of describing these timers is on delay or off delay. So the first one we looked at was on delay, or off delay, which is what this one is. Now, at a point where we haven't energized the coil yet, I think it's fair to say that when the coil is de-energized, we are going to have open contacts that are still normally open and normally closed contacts which are normally closed. Nothing's happened yet. Okay? Now we're talking standard contacts right now. We're just looking at them. What happens when we energize the coil? So now what we're going to do is we're going to come over here. We're going to energize that. That energizes TR1, which these contacts should be showing here. That closes. We have a holding pattern. Not rocket science. You guys are quite familiar with how that works. But what happens when the coil is energized to our standard contacts? They switch, right? Standard contacts operate the same way on every type of timer. So in this case, these guys close, and these guys open. Okay, now let's take a look at the timed contacts. In a normal circumstance, when we're not energized, same thing. These would be normally open, and these would be normally closed. Now, here's where this timer is different than the previous one. When we energize this coil like we've demonstrated up here right now, first of all, have we started the timer as soon as we energize the coil? No, we haven't started the timer. That's the first difference. Timer hasn't started yet. What happens to my contacts as soon as I energize the timed contacts? What happens to the timed contacts as soon as we energize the coil? Wrong, they switch. That's the major difference right there. And I need you to lock that in because your timer off in your programming operates exactly the same way. We'll cover more about that here in a bit. But it's important you understand that even though we haven't started the timer, your timed contacts change state. This becomes closed. This becomes open. Like so. So you need to remember that that's how those off timers work. Okay. Now, as we've already pointed out, just because we've energized the coil, we haven't started the timer yet. What is it that makes our timer start? What do we have to do?
De-energize.
Exactly. We have to de-energize the circuit. So in other words, now what I have to do, if I want to start the timer timing, I have to go up here and I have to open the start button. So this guy, we need to open it, or the stop. Did I say start? I meant stop. We have to open the stop. As soon as I do that, that de-energizes the coil. Now our timer starts. Do my contacts change state at this point? No. So these are still closed, and these are still open. Okay, so contacts haven't changed. However, our timer is timing. We've now started the timer. Now, once we timed out, now what happens to our contacts? They go back, right? So this becomes open, and this becomes closed. Back to its original state. All right, this is the tough one, and this is also the tough one when we get to off timers in PLC programming for ladder logic, but they operate the same way. So if you have a foundation for how these work, it should help you out with your timers in your program. Okay, so given that, let's go take a look at an actual program. So here we have a PLC program in ladder logic. You'll notice we have a limit switch in the very first rung, and it operates a timer. So our limit switch is an input instruction. Our timer is an output instruction. Now, I want to touch on a couple of things. I want to talk about this, and one that doesn't show up beside the timer called TT, which stands for timer timing. Think they are bits just like your addresses on your PLC. So on the PLC, when you guys hardwire an input, that input has an address, right? We've talked about internal bits. They're blank, kind of like spare mailboxes that you can do whatever you want with. This is the same idea. These are also mailboxes or pigeonholes that are either going to have a 0 or a 1 in them, depending on what's happening with the timer. All right, so whether you want to think of all these bits as mailboxes or pigeonholes or however you want to look at them, if they're discrete, which means digital, they're going to have a 0 or they're going to have a 1 in them. That's the only two choices. 1 means on, 0 means off. All right? Now, given that information, we're then going to go through the process here and take a look at what is happening with each one of those bits with this timer on. Now, some key points. TON stands for timer on delay. Okay? It's an on timer. In this case, we're calling it, the label is, it's just labeled timer 1. Now, you guys can label it whatever you want. If you ever get into PLC programming, this timer, the label might say turn on motor 10 after 20 seconds. So you might actually give it a very descriptive label. At this point, for what you guys need to know for your exam here at Lethbridge College, we're simply calling it timer 1. We're just keeping it simple. But you guys will notice on your very last lab, the conveyor belt lab, all of the titles are extremely descriptive. And that's to help the programmer understand what that particular instruction is supposed to be doing in the process. All right, for now, we're just going to call that timer 1. Now, preset is 6,000. Now, your Allen Bradleys are based on microseconds. Milliseconds. 3. So 6,000 actually means 6 seconds. And you guys will have to make a point of when you're doing this. If you just go in and put 6, that's faster than 1 second. That's 6/10 or whatever of a second. So remember, you have to add 3 zeros after when you guys are entering in your time. Okay? So if you want 10 seconds, what would it read? 10,000, right? Sure. Okay? Accumulated. Now at this point, we haven't started the timer timing, so there's no accumulation. That's going to actually, you're going to be able to watch the timer time. Okay, so if the preset here is 6, you're going to actually be able to see it go 1,000, 2,000, 3,000, 4,000, 5,000, 6,000. You're going to be able to watch it as it times. All right. So I'm going to clean this up here a little bit. Now, let's run through the process. Well, first of all, let's just continue to highlight, I guess, what we have for input and output instructions here. So clearly, we have the limit switch in the first rung, which is going to activate our timer. So that limit switch could be on the end of a conveyor belt, for example. Maybe you have a conveyor belt system where there's boxes, and you guys will actually get the chance to hook up that last one, which is a conveyor belt system. But it's an automatic limit switch. A box will hit it, boom, that starts a timer. And then that timer, something's going to happen with the enable bit, which is EN. That's what that stands for, is enable. Think of that as engaging a conventional timer. Okay, when we hit the start button in the conventional timer, the coil energized. Think of this as energizing the coil. Okay, coil energization, even though it's just enabling that bit. As soon as that bit is enabled, what happens to the pigeonhole? Is it a 0 or a 1? It'll be a 1, okay? The done bit, and this is an important piece of information, that bit is not set. Set meaning a 1 is put in its place from a 0. That doesn't happen until our accumulated value equals 6 seconds, or 6,000, okay, milliseconds. All right, so that done bit is right now going to stay a 0 until our accumulated equals the preset. The timer timing, just like our conventional timers, you have to ask yourself, when in a conventional timer does our timer start? Well, think back to our timer on conventional timer. When did the coil, or when did the timer start? At what point in that process? Was it when the coil was energized or de-energized? Timer on. Energized, okay? So is it fair to say the timer timing pigeonhole will turn to a 1 as soon as the enable bit is on? Yes. On this timer. Okay, that's not the case on the timer off, but we'll get there. So you can see that what we're doing is we're referencing right here the timer timing bit. In other words, we're saying to the program, go look at that pigeonhole that has the TT in it and tell me if there's a 1 or a 0. If there's a 1, that means that the instruction is what? True or false? True. All right? If the timer is timing, what's going to happen here? Light's going to turn on. Oh, thank you. No? And what the hell is going on here? I must have undo delete page. Yeah, I deleted a page by mistake. How about that? Is that the one we want? There we are. I must have done that with my arm or something. Now that's sensitive. I wondered where the TT went. I could have sworn I just wrote it up there. So light 1 would come on with the timer timing. Now I want you to take a look at here. So now we're asking the program to reference the done bit. So is it fair to say that light 2 will not come on until the done bit is set? And the done bit won't be set until the accumulated equals the preset. All right, let's run through it. So status, let's call, well, first of all, I'm just going to erase some of my scribbles here. And you guys know what all this is now. So now we're going to trip the limit switch. That's our goal. So we're going to trip. So we're going to limit switch is activated. Okay? So we're going to put yes here. So we've activated the limit switch. What happens to our enable bit, given that it's an on timer? Okay, so that's a 1. Good. Have we started timing? Yes. Yes. Remember, just like a conventional timer, you guys, timer on. So we've started timing. Now, if it's just at the moment when that limit switch is activated, you're going to see the accumulated start to rise. So at this point, what we're saying is we have not reached 6 seconds yet. Okay, so at the point where we are, let's call this less than 6 over here. I think that's actually what I had in my notes now that I think about it. I'm not following my notes very good, you guys. I get going here and I forget to follow my notes. So yeah, I had within 6 seconds, okay? So less than 6 seconds there. We could say that the done bit is still 0. We're not done yet. And our accumulated is somewhere within 6 seconds. So, given that TT has a 1, is it fair to say that this is going to be true right there? Is light 1 going to come on? On. Good. How about light 2? Are we there yet? No, we're still off. Okay. Now we're going to do this. At some point, our accumulated is going to be equal to or greater than 6 seconds. All right, now at this point, what we're saying is our limit switch is still activating. In other words, we've tripped that limit switch, and this instruction up here is still remaining true. Okay? At that point, we're still enabled. Our timer, is it still timing now that it's reached? No. Okay, we've reached a preset, so our timer stops timing. What about our done bit? Yeah, done bit's on, right? So our accumulated has reached the preset, which means the done bit is now set. So the accumulated in this case we're saying is greater than 6. Light 1, if the timer is no longer timing, what happened to this instruction here? False. In which case light 1 goes off. Now what about light 2? Because now, take a look at our done bit. This instruction is true. Light 2 now turns on. Okay? Now I want to point something else out. If this rung stays true, does anybody want to guess what happens to the accumulated value? It keeps climbing. That's exactly right. It just keeps going until it reaches 2 billion. Oh no, that's the counters. It just keeps going. All right? The only way to reset this timer is to do what? What has to happen in that rung? It has to go false. Once that box goes by the limit switch, and the limit switch falls back into its regular position, this goes false. Our accumulated now goes back to 0. Okay? You will notice there is no reset instruction here on timers. We're going to get into reset instruction on retention. Well, we're not going to talk a lot about retention timers, but on counters, you need a reset instruction. That's not the case for timers. That accumulated will just keep going. Okay, let's take a look at time delay on de-energization. So here we have an off timer, and once again, you can see that up top here. It says TOF. In this case, our preset is 10 seconds. Now, in lab class, I'm going to give you a heads up. What you guys are going to want to do is you're going to manually go in and put 20,000 seconds if you want it to count down. It's just a counter, or a timer rather. And so the time, oh actually that's counter, back up. I'm getting my counters and my timers mixed up. Forget I said that, that's counters, we'll get there. My bad. So it's going to start at 10 seconds, it's going to count down. Okay? Same thing applies here, you guys, as far as the accumulated and the preset, with one exception. Let's start with the status. We're at rest. In other words, nothing's happening yet. So we're just sitting there. Our limit switch 2 has not been tripped yet. So limit switch 2, we're going to say not tripped. And we're just going to look at contacts and so on. Limit switch 2 is deactivated. Yes. Now, at this point, the enable bit, is it going to be a 0 or a 1? We haven't done anything yet. 0. Have we started timing? No, so 0. Are we done? No. Our accumulated is going to show accumulated is going to show 10,000. Now, given the status of those 3 bits, timer 2, timer timing, if we're not timing, is light 2 going to be on or off?
Why does your accumulation say 10,000?
Yeah. 0.
Because
It's going to count down. It's going to count from 10 down to 0. Yeah, good question. Okay, now keep in mind that they are just counters, or timers rather, and so timers, you can put in whatever you want, technically. All right, you can change your preset to whatever you want it to be.
your preset should say 0 and your accumulation is at 10. You know,
No.
the other way.
No, well, you can, yes. I got to be honest, I'm not sure how to make that work. I've never tried it. For our lab, I've just left it the way it is. For you guys to put in whatever you want to be your preset. And I think your lab calls for 10 seconds. There is one lab where you have 2 timers. One's going to be 5 seconds, one's going to be 15 seconds. So you would put 5 or 15 in there. Yeah. Although that particular lab, I think, uses on timers, not off timers. But your preset, you can make whatever you want. So, light number 2, we said, is going to be off. So there's going to be a 0 there. That's off. Yes, not a 0. It's off. Because light 2 is being driven by the timer timing, and we haven't started timing yet. How about light 3? This will be on because, why is that? Is this a true or false instruction here? It's true because it's saying go to the done bit and look for an off condition. Is our done bit off? Yes. So it will be on. Catching on, Devin. Yeah. All right. Now let's take a look at limit switch is activated. Yes. And so that one is null and void. As soon as we do that, what happens to our enable bit? Have we enabled the timer? Yes. It's a timer off. Have we started timing yet? Good. There's the million-dollar question. So when you think back to your conventional timers, that timer doesn't start until this rung goes false. At this point right now, and I should have written that in, that's true and this is false. That's where we're at right now, right? Actually, no. Sorry, back up. The timer timing, yes, it's still false, isn't it? We're just talking about that. Sorry. So this is 0. Come on, bugger. 0, 0. So this is 1, and that is still 0. So this is a false statement, like 2. The done bit, are we done yet? Thank. What happened to our contacts on our timer, on our off timer, on our conventional timer? The timed contacts, what happened to them right away? They close. I want you guys to think of your contacts on your conventional timer as your done bit. This is the big one right here. The done bit, as soon as our timer is enabled, goes to a 1. So again, think of the done bit as the contacts on an off timer. They change state right away. So our done bit is set. Now our accumulated, we haven't started timing yet, right? So nothing's changed in that part. Oh yeah, you know what, Travis? You're right. Why am I putting 10,000 there? I'm an idiot. It should say 0. You were right. I'm still thinking counters up here. When we get to counters, you guys, I'd be right. But we're still on timers. I'm a little bit ahead of myself. Can you guys do me a favor, accept my apology for screwing that up, A, and then B, put 0 in there for me? Accumulated 0. We're not talking counters, we're talking timers. I get this confused every bloody intake. Point being is that now, like 2, we have to look at the timer timing. At this point, it's still false, right? We haven't started the timer yet. Okay, because that our timer timing bit is a 0. So this is going to be off. What about light 3? What just happened to it? It turned off because what happened to our done bit? This is saying examine for an off condition. When it goes to the pigeonhole and looks for a 0, which would make it a true statement, it finds a 1. Doesn't that make this false? Yep. So light 3 goes off. All right? Okay, now what we're going to do is we're going to say the limit switch is deactivated. It went false. Okay, so we're going to go up here and change that, and we'll look at these bits again. So this went false. As soon as it goes false, what do you think happens to the enable bit? Are we enabling the timer anymore? No. So it's going to be a 0. Now, talk to me about the timer timing. What's going on there? It starts timing. Just like we hit the stop button in the conventional timer, now we've activated the timer. TT now has a 1 in its place. So we start timing. So we're going to assume for this particular part that we have not reached our accumulated value yet. We're just in the process of timing, okay? So are we done yet? That's still changed, you guys. That's not changing back until when? When would that done bit change back to 0? When it's done timing, sure. We're not done timing yet. So our accumulated is going to be somewhere between 0 and 10. Okay? Let's take a look at light 2. Is my timer timing? Yes. That's a true statement now. What happens to light 2? Goes on. Light 3. Is the timer not done, or is it done? Take a look at pigeonhole. Is the done bit set? Is it true or untrue? So nothing's changed. This is still false. This says go to that pigeonhole and look for a 0, meaning look for an off condition. If it's off, that's true. Well, it's not off, it's on. So we're still false. So this is off. Okay, 10 seconds are up. Now at this point, I haven't changed the state of the limit switch because we were timing, right? So let's go back and we're going to leave that limit switch false. It went false, it stayed false. We have to look at some bits. Okay, so at this point, limit switch 2 is still deactivated. And yes. The enable bit, we're still unable or enable, if that's the correct word there. Our timer timing. Has our accumulated reached the preset now? Yes. So are we timing any longer? No. That goes 0. What happens to our done bit? Goes 0. Good. Accumulated is greater than 10. 10 or greater. Let's take a look at light 2. Timer timing? Nope, timer's done. False. What happens to light 2? Off. Let's take a look at light 3. Timer 2 not done. Are we not done in this case? Yes. With a 0. Not done meaning it's looking for an off condition where our done bit is off. It has a 0. So what happens to light 3? On. Okay? All right. Let's take a look at counters. Now counters are similar to timers, you guys, in the sense that the actual instruction looks very similar. And like I said, you can clearly see I always get these darn things mixed up, the timers and the counters. It's easy to do. But we're going to work through it. So here we have a limit switch again. We have a counter, and similar to a timer, CTU stands for counter up. We've labeled it counter 1. Now again, in industry and process, usually that might be a bit more descriptive. For lab class, you don't have to worry about it. The preset is 10, and we're going to start counting, and you're going to watch the accumulated every time this limit switch is tripped. So think of a conveyor belt system. It's a great example. It's going to count 1. All right, and it's going to count 1 every time. So what has to happen here, if you can remember this, is that the limit switch has to go true. That'll count 1. Then it has to go false. If it stays true, you stop counting. It doesn't go up. It goes up every time we go from true, false, back to true. It counts again. That's how the counter works. Whether we're going up on a counter up or whether we're going down on a counter down. So we have counter 1 done. Again, we're looking at the done bit. Now you'll notice rather than it saying enable, we have CU. It's the same idea. That just means we've enabled the counter. So or enabled the coil, kind of like a conventional timer. We have a light, and then we have a second limit switch. And this is what's a little different than your timers, other than the retentive timer, which I'm not going to get into today. Your limit switch here actually operates a reset function. Okay? That reset resets your counter. If you don't have this instruction, what do you think happens to the accumulator? Just keeps counting. And it keeps counting until it gets to 2,147,000,000. It's a real crazy number. And we're going to talk more about that in lab. But that's called, if it continues to count, there's an overvalue bit. It's not super important. Overvalue simply means when we reach that 2 billion and change, that bit will be set. And it's more often or not used as a safety in case the reset doesn't happen to shut the process down. Again, not super important for what you guys need to know for lab, but just understand there is a couple of other bits in there, overvalue and undervalue for the counter down. Not super important, but they are there. Okay, so that's kind of how this thing's going to work. So let's go through the process. We're going to start by looking at this thing at rest. In other words, nothing's happening. So limit switch 1 is false. Limit switch 2 is false. And just by the way, you guys, that limit switch 2, you can put false more or less all the way down that column. It's going to stay false for a long time until we get towards the end. Why does it say CE here? This should say CU. See, I haven't fixed that. That should say CU, you guys. And we have a counter up here. So at this point, have we engaged the timer or the counter? No. So this is going to be a 0. Have we counted anything yet? No. So that's going to show a 0. Are we done? No. So our accumulated hasn't equaled the preset. So that's going to be a 0 in that pigeonhole. And the preset is still 10. Let's take a look at light 1. If counter 1 is evaluating the done bit shows a 0. So is the light going to be on or off? Off. All right, now let's make limit switch 1 go true. Again, limit switch 2 is going to be false for quite a while. Limit switch 1 goes true. We now have a path of true statements through to the counter. Counter up, what happens to that pigeonhole? Have we engaged the counter? Yes. What happens to our accumulated value, do you think? Counts 1. Are we done yet? No, we got to get all the way up to 10 before we're done. So our preset is still 10. Given that the done bit has not been set yet, it's fair to say that light 1 is still off. Now, I'm going to erase this, and we're going to make limit switch 1 go false. Okay, so this is going to go false. Again, limit switch 2 all the way down is pretty much going to be false. Have we engaged the counter? No, so this goes back to a 0. Think of it as an on-off switch, you guys. The enable on the timer and the CU or CD on the counters, think of it just as an on-off. We either turn it on or turn it off. The actual timer, not the, or the counter. Remember, that doesn't necessarily start the timer, it just engages it, okay? Our accumulated is still 1. That part hasn't changed. We're not done yet. We had a long way to go. Preset still 10. Light 1 is off. So you can see when that run goes false early, the only thing that changes is your CU. Now, I'm not going to go through this 10 times. It will be here all day if I did that. So what we're going to do, we're going to do this. We're going to put a nice squiggly line, or you could do this, true, false, blah, 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 blah. We get down to there. And again, the false, that's going to be the same all the way down to say there, okay? And then we're going to put in there after 10 changes. I'm out of room here, but hopefully you guys can squeeze that in. So in other words, we're going to make that limit switch 1 go true for the 10th time. Okay? Limit switch 2 is still false. Are we engaging the counter? Yes. What is our accumulated at this point? What's the number going to be after 10 changes? 10. Good. Are we done? Yes. Our preset is, that's never really changed, is 10. Now what happens to light 1? Go up and take a look at light 1. Is counter 1 done? Is this a true statement? Yes. So this light 1 turns on. Now, as I pointed out, if that limit switch 2 doesn't get tripped, what happens to our accumulated value here? It just keeps going up till that 2 billion mark. Now what I want to do, though, is I actually want to trip and make limit switch 2 true. So we're going to actually go and we're going to make this guy true. And we want to see that that actually counter 1 will now reset. So we've got to go through the bits and just see what that does. So if we reset that, this goes to 0. Our accumulated goes back to 0. Our done, we're not done anymore because now our accumulated doesn't equal our preset, right? So that goes back to 0. Our preset's still 10, and of course, what happens to light 1 now again? Off. Right? Any questions on that before we move on to the counter down?
Limit switch at that point is false.
Oh, yes, limit switch 1, good question, Carson. We're gonna assume on the 10th change, or it could actually be, if it's, well, let me put it this way. We're gonna call it false because that would make the rest of what we just did make sense on that run. But what happens, let's just explore this for a second. What happens if this thing stayed true and I hit a reset? Let's see if we can't think this through. Exactly. Who said that? Good call, Riley. Yes. It's going to reset because that's a reset instruction. So it's going to do everything we said on that last one, but immediately it's going to go to 1 because that instruction is true ahead of the counter. Yeah. Good. All right, let's look at a counter down. Same setup, you guys. Except I want to point out, this is what I was blabbing about before where I always get confused, is your accumulated you're going to want to set to be higher than your preset because we're counting down. Timers, you don't have to worry about that. It just times. Okay, but counters, you're going to manually go in and you're going to put whatever number you want here. You can do it. Just have to click on it. I can't remember if it's a right click or left click. You guys might have to play with that a little bit. I'll see if I can't remember here before lab class. But point being is, this is going to actually be a higher number than the preset. Now, There is such a thing as a move instruction that you can insert here where it will automatically reset this, in this case to 70 every time there's a reset on the counter. We don't get into that level of programming, although it's not that hard to insert. It's not part of the lab, but just so you're aware, in industry, you're not going to have an operator going back here manually putting in a number every single time this thing gets reset. That's not practical. So there is an instruction that will automatically do that for you. But for lab class, because you're only doing it once, we're going to have you manually enter that number. So everything else is the same other than you notice it says CTD, and instead of saying CU, it says CD right there. But it operates the same way. Okay, that really just is an engagement of your counter. So we're going to do the same thing here. We're going to take a look at the limit switches, and we're going to start in just the off state. And we're going to say limit switch 1 at this point is still false. Limit switch 2 is going to be false, just like it was on the other one, all the way down to the bottom. If my limit switch 1 is false, have we engaged the timer? Or the counter, rather? No, so that's going to be a 0. Accumulated is still going to be at 70. We're not done, so that's going to be 0. And our preset is still 60. And therefore, light 1, it's looking for the done instruction to be true, but because it isn't, it's fair to say that that's going to be off. Now let's make limit switch 1 true. As soon as we do that, we're assuming limit switch 2 is still false. Have we engaged the counter? Yes. So this goes to a 1. Our accumulated now goes to what? 69. Are we done? No. Our preset's still 60. Our light is still off. Now again, I'm not going to go through this 10 times, or I'm going to throw in a little curveball here and use the number 11. I'm not going to go through 11 times. I'll talk more about that here briefly. So here's actually, I'm going to talk about it right now. This clearly is going to go false, true, and count, just like the other counter did. I'm not going to go through it 11 times. Now, why do you think I'm using the number 11 instead of 10, like I did on the previous counter? You're on the right track, but not quite. Let's go back to the counter up. When we counted up, it took 10 transactions, then your done bit was set, right? Your accumulated equaled your preset. On a counter down, you have to go 1 past. That's why I'm kind of trying to lead you into it there a little bit. So you're going to have 10 transactions. That doesn't change the done bit until you go 1 past. You need 1 more transaction. You guys need to remember that if you're going to get tested on it. I guarantee you, somebody's going to get that question. Okay, so unlike a counter up, your accumulated has to go 1 past your preset in order for your done bit to be set. So we're going to go like this, and we're going to say after, instead of 10 times, we're going to say after 11 times, 11 transactions of true, false, true, false. And again, we're still assuming limit switch 2 here is still false. At that point, after 11 transactions, we know that our CD, we've engaged our counter. Our accumulated is going to equal what now? 59? Is our done bit now set? Yes. Our preset was 60. Is light 1 going to be on or off? On. Good. Now, not unlike your counter up, you guys, if we don't have limit switch 2 trip the reset, what do you think happens to the counter? It just keeps going till it reaches minus 2,147,000,000 and change, whatever that number is. It's in your lab pack if you want the exact number. Okay. So once again, then we're going to say limit switch 2 now is going to go true, assuming this is still false. Okay, we're going to assume limit switch 1 goes false and limit switch 2 goes true. We know that gives us a reset. So a reset, that means we disengaged our counter. Now at this point, this is where you would have to manually enter 70 back in your program, okay? After the reset. Again, there's that move instruction, I'm not going to get into it, that would automatically do it for you, but if you want to tell where you had to do that, right here. After you hit the reset, and you're going to have to go back in, you're going to have to manually enter 70. Okay, clearly we're no longer done, and our preset's still 60, and of course, the light will go off. Alright. Well, I thought that was darn near a full lap. Oh, I'm going to stop recording here.